So lesson number 3 looks at factoring trinomials of the form a f of x squared plus b times f of x plus c, where f of x could be a monomial. All it means is right now our trinomials that we've factored have always been kind of in the form of something x squared or m squared or n squared. The variable's been squared in the first term. It's a single or a 1 degree in the second term, and then nothing in the third term. If there was something there, it might have been like an x cubed, an x squared, and an x, so x was your GCF and you pulled that out. But what happens if I have x to the power of 4 plus 5x squared plus 6? Well, if I go to factor this out, all of this explanation here is just kind of overkill. How would I get x to the power of 4? If I have two binomials that I'm multiplying together, how am I going to get x to the power of 4? What am I going to multiply together? I'm going to multiply 2x squareds. So all of this explanation here, we don't need quite all of that. I know that I'm going to multiply 2x squareds, and the reason why it has to be x squareds has to do with that middle term. I can't do an x to the power of 3 and an x, because when I go to try to distribute this out, I'm not going to get that x squared that I need for the middle term. So this middle term actually goes to help with what am I supposed to get here. And then the 5 and the 6, two numbers that multiply to 6 and add to 5. 3 and 2. And they're both positive. So now when I expand this out or FOIL it, I get x to the power of 4. There's my 3x squared and my 2x squared, which gives me 5x squareds, and then my 6. So the explanation that is done here has to do with making a substitution. We are going to look at eventually doing substitutions, but I don't think we need to substitute for these questions. What we can use is this middle term. This middle term is always going to tell me what I should have for kind of my first and my last in terms of variables or even some of my numbers. So let's look at class example number 1. 5a to the power of 4, and this is an a squared. That's my clue that these should be a squareds. Because my coefficient is a 1 here, this is that sum and product chart. Two numbers that multiply to negative 14 and add to negative 5.
Negative 7 and 2.
So try to factor B and C. So how would I factor B? What would B look like factored?
X squared plus 5, x squared minus 1.
Okay? What can you tell me about x squared minus 1? It's a difference of squares. So is this right now factored completely? No. So I need to factor this one out. So the x squared plus 5 will stay. But what becomes of the x squared minus 1? What do I get when I factor it out?
X minus 1, x plus 1.
Yep. So just like before when we had to look to make sure there wasn't a common factor that I could pull out of my factored binomial, I have to make sure that these binomials are factored completely. Really what I'm looking for is there a difference of squares I can factor. So let's look at C. This time I have an x to the power of 6, but my middle term is an x cubed. So that should be my hint that these have to be x cubes. So then I have two numbers that multiply to 14 and add to negative 9.
Negative 7 and negative 3.
These are not a difference of squares because I can't take the square root of x cubed nicely. So that is in its factored form. The examples on the following page look at the decomposition method. With this decomposition method, I'm not going to go through the decomposition part. What I am going to go through is how can I do this by sight? How can I look at this and factor it? So I know that when I factor it, I'm supposed to get two binomials. And I can do this by sight because this is a -3. And the only way that I'm going to get a -3 is I have to have a 3 and a 1. In order for it to be a -3, one of those two have to be 3, one has to be positive, one has to be negative. So I can't put that in just yet. And then I've got this 4y to the power 4. So I know I need a y squared in each of these. But again, now this is where the mental math comes in. To get 4, to multiply something out to get 4, I can either go 4 times 1 or 2 times 2. And then my outside and my inside, so when I go like this and like that, those two expansions have to give me my -11y squared. So if I start looking at my numbers and start playing with things, if I put a 2 and 2 here, I'm going to get a 2 and I'm going to get a 6. And because one of them will have to be positive and one will have to be negative, I'm finding the difference between that outside and inside. So the difference between 2 and 6 is going to be a 4. That's not what I need. So that eliminates the 2 and the 2. So now I have 4 and 1, and I need to probably be certain that I would use the 4 and the 1 at this point because 2 and 2 didn't work. I just have to figure out where would I put the 4 and where would I put the 1. Well, if I want this to be 11, what do I want to multiply by 3? I'm going to want to multiply that 3 by 4. Because if I multiply the 3 by the 4, I'm going to end up with a 12. And then this is going to give me a 1. So I've got 1 times 4 gives me my 4y cubed. 3 and 1 gives me my 3. And then I've got 12 and 1, the difference of which is going to be 11. To make it a -11, make this a -12 and a +1. So the first while that you try to use this method, it probably will take you as much time as decomposition, but after a while it will become faster than having to go through all the steps of decomposition. And the questions that I give you, I will always give you a prime number. So I will give you a prime number either in the first or the last spot so that you could do this, because I want you to practice this. It's going to be faster in the long run. So if we look at class example 2A, because it's not, they're not prime numbers, I would have to do my decomposition. So when they're not prime numbers, try decomposition. When they are prime numbers, try the sight method. So if I'm doing decomposition, that's my product and sum chart that I have to start off with. The sum is always the middle term, but the product this time is the outside two terms, which is my -24. So two numbers that multiply to -24 and add to -5. So then 4x squared minus 8x plus, or sorry, that wouldn't be squareds anymore. 4x to the power of 4 minus 8x squared plus 3x squared minus 6. And then I can factor through grouping. So I'll let you finish that up. When I go to finish this up, from the first two terms, I can take out a 4x squared, leaves me with x squared and a -2. I can take out a +3 And I should end up with an x squared minus 2 again, because that would be my common factor. And then I'd be left with a 4x squared plus 3. Double check that this is not a difference of squares, because I have two terms. It's not, because I can't square root 2 nicely. So that ends up being its factored form. With b, I have a prime number. 2 is a prime number. The only way I'm going to get that 2 is to multiply 2 by 1. And the middle term tells me what that first term should have in it. It should have an a and a b. So this should be 2ab and 1ab. So that when I multiply them together, I get my a squared b squared. Now the next one is my 99. How can I multiply two numbers together to get me 99? Well, there's 99 and 1, 33 and 3, and then 11 and 9, I think are my combinations. Can I eliminate any of these combinations before I even try them out? Why?
Because you have to get to negative 31, so it's kind of a big number.
Okay. Could I eliminate 33 and 3 for the same reason? Or should I check it? I could check the 33 and 3. If I check the 33 and 3, would I put the 33 here, or would I put the 3 here? If I'm trying to get a negative 31, I'm probably going to put the 33 on this side. So I'm going to get a 6 and a 33. This is positive, which means I have to add these together because they're going to have the same sign. The only way I can get that positive 99 is to have the same signs. So if I add the 6 and the 33, I don't get 31. So that eliminates 33 and 3. Now I have the 9 and the 11. So if I put 11 here and 9 here, I get 18 and 11, which together gives me 29. It's not 33. So if I reverse it and I go 9 here and 11 here, I get 22 and 9, which is 31. Because this is positive and this is negative, both of these have to be negative. So again, it's practice, practice, practice. So class example number 3, I can factor this one using my sight method, again, because I have a prime number, this negative 3. The only way that I can get 3 is to multiply what two numbers together? 3 and 1. Because my middle term is an x squared, that means that my first term is going to be something x squared. So I'm going to give you a couple of moments. What I want you to do is figure out what coefficient should I have in front of these x squareds so that when I multiply them out, I get an 8 here, and then when I go my outside and my inside, I get a 10. So because this has to be a negative 3, one of those numbers has to be positive, one has to be negative. So what I'm doing with my outside and my inside is I'm finding the difference between them. So the key for doing this is understanding how the distributive property works in connection to these 3 terms when I'm multiplying out my binomial. So the 1 and 8 doesn't work because the numbers don't match up. And then with the 2 and 4, if I put a 2 here and a 4 there, I get 12 and 10. The different, or 12 and 2, the difference is 10. To make that a positive 10, I need this to be a positive 12 and a negative 2. Remember what I said? If I have a binomial, check. Is this a difference of squares? Can I square root 4x squared? Can I square root 1? So because these can be square rooted, this is a difference of squares. And I get 2x plus 1 and 2x minus 1. So when it asks you to factor completely, it means you have to look at the terms that you end up with and determine, could I factor it more? Okay, let's take a look at class example number 4 and tell me what you see. Sine squared x can be written as sine x squared. So when you see 6 sine squared x, it means the sine x has been multiplied by itself. The confusion with this is having this sine x. Can you factor that? Actually, I want you to factor that. Ignore the sine x and factor that expression. So this one can be done by inspection because I've got this prime number of 2. Oops, not 2 and 2, 2 and 1. And because this is a positive 2 and this is a negative, these both have to be negatives. And then I need my 6 and something, then I'm going to get a 3 in the middle. So if I try 6 and 1 here, that's going to give me a 12 and 1, that's 13. That's not going to work. If I switch it the other way and I put 1 and 6, I get 8, because I'm going to get a 6 and 2. So 6 and 1 didn't work. That leaves me with 3 and 2. If I put the 3 here and the 2 there, I'm going to get 6 and 1, which wouldn't work. So if I go the other way around, I get a negative 3 and a negative 4, which gives me my negative 7. So I get 2s minus 1 and 3s minus 2. Is that not what you got, Bobby? Yeah?
No, I think it's because we wrote our minus 2 first, and then our minus 1.
Okay, do you have the expression 3s minus 2?
Oh, yeah, never mind.
Okay. I was like, what? What did I say s represented? S is just going to be my sine x. So this is going to rewrite itself like that. Because remember, whatever that middle term is becomes my 2 leading variables. So if I looked at b and I tried to do something similar, get rid of the cos x squared, which can be distracting. And just reduce it down to c to begin with. And if you have to, you could put in a legend. C equals cos x. Now try to factor it, which I can do by sight because I've got that prime number of 3. So with this negative 3, I have to have a 3 and a 1. Because it's negative 3, one of those is going to be positive, one's going to be negative. And then I need the 4, so these being multiplied together need to give me 4, and I need an 11. Well, if you've done this enough and you look at it, the 2 and the 2 I can eliminate right off the bat because there's no way I can get the 11. My numbers aren't going to be high enough. In fact, because I've got this 3, I know if I put the 4 here, I get a 12. And then if I could take 1 away, I would get my 11. So to get my positive 11, I need a positive 12 and a negative 1. And then my c's can go in. So my c stood for cos x. So I get cos x plus 3 and 4 cos x minus 1. So the substitution that was alluded to at the beginning of the lesson that I skipped over for my x to the power of 4s and x squareds, it works when I have a trig expression. It works really well when I have a trig expression. The other place where it works really well is if I stick a binomial in there. So this 7 times x minus 3 squared minus 4 times x minus 3 minus x, if I rewrote it like this, could you factor that? Does this become easier to factor than the original expression? The only thing that I did is I said let x be equal to x minus 3. If you want, you could use a different letter. You could use A. You could use M. Whatever you wanted to represent this expression that's in the brackets. So now take a moment to try to factor that one. So with A, the 7 and the negative 3 are both prime numbers. So the only way that I can get a 7x squared is to multiply 7x by x. And then to get negative 3, the only way I can get the negative 3 is the negative 3 and 1. I just need to figure out where to put the 3 and where to put the 1. Well, if I put the 3 here, I'm going to end up with a 21, which is going to be too big of a number. So 3 has to go on this side, because then I get 7 and 3. For this to be negative, one of these has to be positive, one has to be negative, so I find the difference. The difference between 7 and 3 would be 4. To make it a negative 4, I need a negative 7 and a positive 3. My next step would be to replace and put this x minus 3 back in. And then from this step, I could clean this up by removing the brackets in here and multiplying by the 7, which would then give me 7x minus 18. And on this one, I get an x minus 3 minus 1, which would be an x minus 4. So for B, I have this a plus 4 that's in the brackets. I could substitute that out. And I could use a capital A if I wanted to. In that A equals A plus 4. Can I use the sight method to try to factor this one out? I could. I can use the sight method for any of them. Is it going to be easy to do though? No, because the 9 and the 10 are not prime numbers. So I probably should go back to my product and sum chart. My sum is going to be 1. My product, negative 90. So two numbers that multiply to negative 90 and add to 1. And I talked about this a little bit in the lesson yesterday. How do I know where doesn't matter where I put the 10 and the 9.
Don't you put it with the side that's easier to factor?
I probably do want to put it with the side that's easier to factor, but if I didn't, I could still factor it. So it would make more sense to write this as in this form than to go 9a squared plus 10a minus 9a plus or minus 10. So now I can factor out a 9a, and I'm left with a minus 1, factor out a 10, same thing. So I'm left with a minus 1 and a 9a plus 10. I need to go back because a represented a plus 4. So now I'm going to replace that capital A with my expression, and then clean it up. A plus 4 minus 1 would be A plus 3. I'm going to get 9a plus 36 plus 10, which would be 9a plus 46. So the reason why I use capital letters when I'm doing my replacement is so I get to the bottom and recognize I've never used capital letters in my algebraic expressions before. So this must mean that I forgot or that I have to go back and do something else. So that's why I use the capital letters. It's just a reminder. So the questions that I want you to work on. 1C, 2D, 3B, 5A, and then 7, 8, 9.